All right, I'm here to go over 8.3 notes, confidence interval to estimate a population mean with you together. Um, I don't think I have enough examples, like the ones that you will see on your homework. So what I want to do is after going over the notes, page 1, 2, 3, 4, we're gonna try to look at some Math Lab homework problems together, because I think the ones that you're gonna do on your homework, you will, instead of use the summary, you will actually use the data to create a confidence interval. So that's my goal. I want to go over this notes, talk about how to find 95% confidence interval for population mean, because 8.2 was about population proportion. We'll do that together and we'll look at some homework problems together, okay? All right, opening up the PowerPoint slides or Google Slides. There we go. 8.3 is the third section of chapter 8. We have the fourth one, where we're going to look at how to find the sample size. But and this one is about finding the constructing confidence interval to estimate population mean. Things like what is the true population average height or average weight? Okay, all right. Here are the steps. Step number 1. You first have to find the z-score that correspond with the confidence level. Oh, not levy then. What is that word? Confidence level. I hope I don't have that typo on the notes. Let me double check. I think I fixed it one place. Confidence level. Yes, yes. So the notes is fine. The PowerPoint had a little typo here. So, remember how to find those z-scores. Most common ones that we just kind of memorize, or we can look these up without using the standard table or normal calculators. These are one of the common ones that you will need to use. For 90% confidence level, use z-score of 1.46. For 95%, that's going to be the most common. We're going to use the z-score of 1.96. Okay, and 99% confidence interval or level, we're gonna use the z-score of 2.58. These are the common ones that if you have in your notes, you can use them when you're doing the problems. And step number 2, find the sample mean x bar, and we're going to use that sample mean as the point estimate. In other words, our best prediction or best guess at the population mean. So that's going to be your point estimate, and we'll find the margin of error, add it to the sample mean, and subtract it from the sample mean, and we'll call that the confidence interval. All right, so next you will find the standard deviation of a sample proportion, and it shouldn't say sample proportion, right? You've been doing this with me for a while. It should say standard deviation of the sample mean. And in your notes, yes, standard deviation. I want you to fix that for me, please, okay? Standard deviation of a sample mean. We did sample proportion in 8.2, and I was trying to make similar notes, and I just had a typo there. So fix that for me. Find the standard deviation of sample mean, and you know the standard error formula for 7.3 or 2 when we did the sampling distribution of sample mean. And that was population standard deviation divided by square root of the sample size, right? So you need that SE, you need that standard error. Why? Because now you're going to multiply that standard error by that z-score you found in step 1, and we'll call that the margin of error, okay? The margin of error for blank percent confidence interval, and that depends, like if it's 95%, you're going to multiply the z-score of 1.96. If it was a 90%, then you're going to multiply by 1.46. If it is 99%, you're going to multiply that standard error by 2.58. Depending on the confidence level, you're going to multiply the standard error by that z-score, and that number that you got is called the margin of error, okay? Now, what do you do if you have the margin of error? You add it and you subtract it from the point estimate of the sample mean, and that's how you just find the confidence interval for sample mean or population mean. Now we got a problem though. When you do these confidence interval for population mean, you very often do not know what this population standard deviation is. Now, what we just talked about, step number 1 through 4, and then step 5, we're going to draw a conclusion. This works if you are given, or if you know how to estimate the population standard deviation. So we'll do one together when we know the population standard deviation. But in this lesson, we will also talk about what are we going to do if we do not know the population standard deviation. Okay? All right. Example number 1. A sample mean, sample size, and population standard deviation and confidence level are provided here. So these are the 4 numbers that we need in order for us to find the confidence interval for population mean. Let's use this information to obtain a confidence interval. Remember those 5 steps. What was step number 1? You need to look at the confidence level and determine the z-score. So remember, z-score for 95% confidence is simply 1.96. Remember that number, we're going to multiply that to the standard error. What's the point estimate? What's that point that we're going to add and subtract the margin of error? The point estimate is the x-bar or sample mean, which is 24. We were given that. Now, we don't know about the population mean, so we're going to use our best guess, which is the sample mean, to predict that, okay? All right, number 3, we're going to find the standard deviation of it. Here we go again. It says sample proportion, but we're finding the standard deviation of the sample mean. So please be nice and please fix that for me on your notes, okay? Well, that's the right formula though. And that standard error is going to be population standard deviation divided by square root of the sample size. We were given these numbers, so write down that standard error is 44 divided by square root of 33, and 44 and 33 were just given to us, right? They gave us the standard deviation for population is 44 and the sample size is 33. That's why the standard error is 44 divided by square root of 33. And if you type that in your calculator, you will get a decimal 7.659. Now, what are you going to multiply this number by? You're going to multiply this number by 1.96, right? Because 1.96 is the number for 95% confidence level. So here's the margin of error. The margin of error is z-score times the standard error that we just found. So do 1.96 times 7.659 and you will get the margin of error is 15.01. This is a number that you're going to add or subtract. You're going to add the 15.01 to the point estimate of 24 to find the upper limit. You're going to subtract that 15.01 from 24 to find the lower limit. And that's how you find the confidence interval. It will be nice to know what we were talking about, like the context of it. But then what we know is that we are 95% confidence that we will be able to capture the true population mean. And that's going to be within 8.99 to 39.01. So step 5, here's the conclusion from our result. At the 95% confidence level, we estimate that the mean of the population, that's what we want to estimate, right? Not mean of the sample, we know that's already 24, but mean of the population that we don't know about is at least 8.99, but no more than 39.01. 8.99 was a lower limit, and 39.01 was the upper limit. So what we can say is that the point estimate of 24, that was the sample mean, that has a margin of error of 15.01. After understanding, you completing the confidence interval for sample proportion. This is very similar, isn't it? We're just using a different formula for standard error. All right, Can you do this in StatCrunch? Of course you can. So this is what you're going to do if you want to use StatCrunch. Click on Stat. Look carefully. Where are you going? You're going to Z Stats, right? And then you're going to one sample and click on with summary. Now, on the homework that you're going to do for confidence interval for sample mean, we're going to be using with data function later, okay? But we were given the summary. We know we were given the sample mean, standard deviation, and everything. So click on with summary and then really type in everything that you were given. Sample mean was 24, standard deviation for population was 44, and sample size was 33. Click on the confidence interval for mu. Mu stands for population mean, right? And the level that we want is 0.95 for 95% confidence interval. Click on compute. Ta-da! They will give you this confidence interval, 95% confidence interval. With a sample mean of 24, they didn't list the margin of error here, but you know how they got the lower limit and the upper limit is by multiplying this standard error by 1.96. So you just have to round it a little bit, but then that's the same thing as what we got by doing it by hand. So you can do it two ways. You can do it by hand or you can use the StatCrunch, but this is where you're going to have to go to find the confidence interval for population mean, okay? Let's go over some couple notes about this confidence interval for population mean. If you don't know the population standard deviation sigma, and that happens very often, if you may get a problem and they have no idea what the population standard deviation is, we estimate by the sample standard deviation. So we're just going to use the same exact formula, but we will, instead of using population standard deviation for the numerator, we will use sample standard deviation. However, using the sample standard deviation instead of the population standard deviation introduces an extra error, right? Because look, we want to estimate population mean, but just because we don't have population standard deviation, we decided to let's just go with sample standard deviation. That's us bringing in extra error to this. So if you do that, to account for this increased error, we must replace the z-score by a slightly larger score, and those are called t-scores. The confidence interval then is then a bit wider because we got extra error brought into our formula. And this distribution is called t-distribution. All right, let me summarize this. There is a new guy in town called t-score and t-distribution. And the important point is we use t-score and t-distribution when we don't know about the population standard deviation. Okay? So when a problem doesn't give you a population standard deviation, then you must use the sample standard deviation. And by doing so, you're bringing in extra error. That's why instead of using z-score, we must use the t-score. So for the rest of this lesson, what I'm going to focus on is how to find these t-scores, just like how we found the z-score in section 8.1. Because you need to use the t-score and use the t-distribution very often because we're not going to know what the population standard deviation is. Okay? Compare this t-distribution to the z-distribution for me. The standard normal distribution is graphed in blue color. There is less variability than t-distribution. And as you can see, t-distribution is based on something called DF. And DF stands for degrees of freedom. We're going to talk about how to find this degrees of freedom. Depending on what the degrees of freedom is, the shape of the distribution, t-distribution, will change a little bit. But mean for t and for standard normal is both 0. Okay? Now let's talk about t-distribution and its properties a little more. the t distribution resembles the standard normal distribution. You notice how they look almost the same, right? They are very similar. It is bell-shaped and is around, the mean is at 0. So it is bell-shaped around a mean of 0, just like standard normal distribution. But t distribution has thicker tails than the standard normal distribution, and it is more spread out. It has more variability, so it's more spread out. Its standard deviation is a bit larger than 1. That's what creates this more spread. The probabilities depend on something called degrees of freedom, and we're going to abbreviate it as DF. And this is how you find the degrees of freedom. You do sample size minus 1. That's what you do. Degrees of freedom is sample size minus 1. For inference about a population mean, here we go. The degrees of freedom equals n minus 1. 1 less than the sample size of n. So if your sample size is 26, then your degrees of freedom will be 26 minus 1, 25. If your sample size is 100, degrees of freedom will be 99. Okay, that's how you find the degrees of freedom. And depending on the degrees of freedom, your t-score will be different. So make sure you know how to find the degrees of freedom. It's just sample size minus 1. Last bullet point, a t-score multiplied by the standard error gives the margin of error for the confidence interval for the mean. Now, exactly the same, right? Because when the cases we knew about the population standard deviation, we were free to use z-score, and we multiplied that z-score by the standard error, and that's how we found the margin of error. But for the cases you don't know the population standard deviation, then you're going to do the same exact process, except instead of z-score, you're going to multiply the standard error by the t-score. But everything else will be the same. So let's spend some time talking about this t-score. Now, this is a t distribution, and you understand these symbols though. Take a look at the very first symbol, x bar. That is the sample mean. This guy is the starting point. This is your best estimate. This is your best guess at the population mean. If you want to know what the population mean is, the best guess will be your sample mean. That's why you keep that as your midpoint. You're going to add or subtract. Now this part that I'm circling, that part right there is called the margin of error. The way they wrote this, that may be a little confusing, but what they are saying is this. The t value that is associated with having 0.025 area to the left of it. Why do you think that number showed up? 0.025. Let me show you where they got it. Guys, what is the most common confidence interval that we calculate? 95%, right? So if you do 95%, if you do 100 minus 95, it's 5%, right? Having a 95% confidence interval, it means that 95% of the data are in the middle. That means to the left of it, to the right of it, we have 5% together. If you divide that 5% by 2, you get 2.5. And 2.5% in decimal is exactly 0.025. So that's just like how we found the z-score using the table. We're finding the t-value that has 0.025. Oftentimes, t-distribution gives you the numbers to the right of it. But we're going to use the StatCrunch to look up these critical t-values, okay? But that's what that means. T and the subscript of 0.025, that just means the t-value that's corresponding to 95% confidence interval, okay? All right, going back. And what are they multiplying this by? They're multiplying this by the standard error, but this standard error got some extra error to it. Why? Because we're not using the population standard deviation of sigma. We're using the little s, and little s stand for sample standard deviation. See? That's why we gotta use the t value here. And whenever you're using t distribution, we must provide, or we must have, in order for us to look up that number, we need to look up that degrees of freedom. And degrees of freedom is simply going to be sample size minus 1. That looks a little confusing, but we can do this. So, this is a great slide, I think. You may want to circle that number 2.447 because that's the t-score. That's the t-score for 95% confidence interval. Just like it's convenient for us to memorize z-score of 1.96 for 95% confidence interval, t-score of 2.447 is for the 95% confidence interval using the t-distribution when we don't know the population standard deviation. So 2.447, but why don't we look this number up together? Oh, whoopsie. Oh, I'm being so bad. Guys, forget about what I just said. Don't memorize it. This number is only good for what? Degrees of freedom of 6. So T number, there's no good number to memorize. We're going to have to look it up every time. Why? Because that number will depend on the degrees of freedom. I was just going so, But only if the sample size is 7. Why 7? Because if degrees of freedom is 6, sample size must be 1 more than that. So only if you got a sample size of 7, then this 2.447 will be great for the 95% confidence interval. Otherwise, we're just going to have to look up this t value all the time. Okay? So sorry I almost messed up. I said memorize. No, don't be memorizing any t-score as they will always change. So this is how you can look it up. Based on the degrees of freedom, which can go from 1, 6, 1, 2, 3, 4, all the way up to however big the sample size minus 1 is. These are some numbers, and the number that they used on that previous chart was 2.447. And that number is coming from wanting the 95% confidence level with the degrees of freedom at 6. But look at that. The same exact 95% confidence interval may ask you to use this different t-value of 2.365 if the sample size or the degrees of freedom is 1 bigger. So that's why we have to always look up these new t-values and can't really memorize 2.447 or 1.96, just like how we did the z-score, because it depends on the degrees of freedom, which depends on the sample size, and sample size are not always the same. All right, let me read this. The scores have right tail probabilities of 0.1, 0.05, and you know how they got these numbers. If you have 80% in the middle, you have 20% to the left and right of it together. So half of 20% is really 10% to the right, so and so and so. But I'm not going to use this table method because I want to do a little more accurate. So what we're going to do is we're going to use the t-distribution calculator, t-calculator on StatCrunch. So I think the last example for this section is really just looking up t-values. And I'm going to have to start another video recording where we actually create these confidence interval using data on StatCrunch. And we'll do that by going over a couple of homework problems together. But let's look at example 2. Using a t-distribution table or software or calculator, let's go with the software option, report the t-statistic, which is multiplied by the standard error to form the margin of error for the following cases. So simply finding the t-statistics. We're not really going to find a confidence interval, but if you know the t-value, then you know how to multiply and create the confidence interval and everything. So first, if you want to create a 95% confidence interval for a mean with 99 observations, they're not asking you to actually create a confidence interval. They're just asking you, what's the t-value that we should use? Now take a look. They gave you n is 99. N is 99. So what is the degrees of freedom? If n is 99, degrees of freedom is 98. You simply subtract 1 from the sample size, and that's how you find the degrees of freedom. Now, what you want to find is this. Notice that we have 95% in the middle, right? So this is how we got that tiny number. If you have 95% in the middle, I'm going to do 100 minus 95, And that's 5% to the left and right together, right? To the left and right together. So how much is to the left of it? If I divide that by 2, I get 2.5%. And 2.5% in decimal is 0.025. So what I want to find is t of 0.025 of the t-value that has 0.025 to the left of it or to the right of it. Since it is symmetric, it's going to be the same. It's just going to be negative or positive. All right, so let me show you how we do that. Just remember that degrees of freedom of 98, and then that we're looking for the corresponding t-value that has 0.025 area either to the left or to the right. So go here for me. If your problem or if your homework or exam problem asks you to find the t-value, go to stat, go to calculators, and go down to t. You're going to look up a t-value, so go down to t. Are you there? Okay. Now this is a t calculator that we can use. Look what I typed in for df. Degrees of freedom is 98. Now this is what I did. I just, I wanted to find which t-value has 0.025 to the left of it. So I typed in 0.025 on this blank on the other side of the equal sign and left this blank because I want them to compute which t-value will have such area. And then I hit compute. Ta-da! So they did it for me. So what's the t-value? The t-value is going to be negative 1.98. So that's the t-value that I'm going to use. And remember, for the margin of error, you're adding or subtracting, so it doesn't matter. The t-value comes out to be positive or negative. Maybe on your homework, you just want to get rid of the negative sign and give them 1.98. That's the t-value. So that's how you will make a confidence interval. You will do x bar, the sample mean, you're going to plus or subtract, you're going to add or subtract that 1.98, that's the t-value we found, times the standard error. And we just have, this is all we can do for this problem because no one in this problem gave us the sample mean or the sample standard deviation, okay? So that's what we do. Just looking up the t-value, let's do another one. What if we have, well, look, it's exact 95% confidence interval again. Now, if we knew the population standard deviation, then we don't need t-value. We just do what? A z-score of 1.96. But we're going to look up the t-value because we don't know the population standard deviation. Notice that the sample size is 19. Then the degrees of freedom will be 19 minus 1. So use df equals 18. And 95% use that same 0.025. And this is what I typed in my t calculator. Type in degrees of freedom is 18. And then the probability to the right of it, to the left or right, doesn't matter, is 0.025. And you know what? You can change the symbol. You just get the positive of it. It doesn't matter. But if you click compute, you will get the t-value to be negative 2.10 or positive. Because as you do the margin of error, you will either add or subtract this number. So the confidence interval will be x bar, the sample mean, plus or minus the margin of error, which can be found as the product of our t-value, 2.1, and the standard error, okay? Very last one, 99% confidence interval. Now take a look. If you want 99% confidence interval, you want to have 99 in the middle, right? So that means to the left of it and to the right of it together, you will have 1%. So if you just look at half of it, then you're going to have 0.5% to the left of it. And 0.5% in decimal is 0.005. So I'm going to find the t-value that has 0.005 to the left of it in this case for the 99% confidence interval. So this is what I do. First, what's the degrees of freedom if you have 19 observation? The degrees of freedom is always n minus 1, so the degrees of freedom is 18. Now, just like how I showed you how I got this number 0.005, I'm going to find that on StatCrunch calculator. Notice I typed in degrees of freedom is 18, and on the other side of that equal sign, I want the probability to be 0.005, and left the blank for t-score blank and hit compute, it's going to give you that the t-score is negative 2.88 rounded up. I rounded it up, but it can be positive. Because some t-distribution just use the right side of it. But hey, that's it. That's how you find the confidence interval using the t-value. You'll have your x bar, the point estimate. You're gonna add or subtract the margin of error, and the margin of error will be a product of that t-value that we just found, and the standard error. In this case, we can't find it without knowing the sample standard deviation. All right, so I think it's time for us to look at a couple additional examples from my math lab homework. But let me go ahead and stop this video because we are done with the notes, and I will be back to go over a couple homework problems together very shortly, okay?